You ready?
Okay.
Okay. All right, we're ready to start our next session. Again, this will be a short 25-minute session. Presenting about modular VDEplug is Professor Renzo Davoli from the University of Bologna.
Is mic working?
I don't think so.
Oh. Maybe. Okay, now I think it's working. I'm presenting this talk trying to get you an update about the new developments of virtual square tools and concepts, especially in the part regarding the networking. It will be a common line seminar, so the slides are VI slides. Just so, VDE, Virtual Distributed Internet, is a tool which is quite used and known to create virtual distributed Internet. The name says all. There are virtual switches, which are processes that works as physical switches, so you can plug your virtual machines. Now we are redesigning all the tools, and we have started from the VDEplug. VDEplug was a tool and a library. It's the library that many common virtual machines and other tools use to connect to VDE. And it's a tool to connect several networks. We have redesigned this from many points of view. First of all, we have created a new syntax to name the VDE networks. It's similar to a URL, and you can say which technology you're using and specifications, and it's plug-inable, so you can add your own implementation of the network. If you want to use a technology, say foo, you just have to create a libslirp underscore foo.so shared library, and your VDEplug will be able to use that kind of implementation. We have implemented the connection with the legacy VDE switches, but this is not interesting, this is the past. You can join top virtual interfaces, UDP, PDP, and so on. But this is just a new point in the dimension of flexibility. But there is much more. We'll come back to this slide. I'm in a hurry to show you this. The XVD, I introduced this 2 years ago here at FOSDEM. It's a way to create a local area cloud. Instead of connecting a virtual machine to a local switch, you connect your virtual machine, or as we will see in a moment, your namespace, to a local cloud. This local cloud is identified by a multicast IP address, so you can have so many local cloud VLANs as many IP multicast addresses you have. And the usage is straightforward, because you just put as a VDE specification that strings, and you have the network. I could have come here with an entire data center, but I have a Raspberry Pi on the table, and so I have a small data center composed by my laptop and the Raspberry Pi, which are just on the same run. There are no processor streams running, and I can start a virtual machine on my laptop, let us say a KVM. Let us use, so, external disk images. Let us start with, there is a command you can see on the top. I just started one more specification. You can see it wrapped around that VDE interface isn't clear because now my default route is on it's on the Wi-Fi. So I have to say that I want to use multicast or on Ethernet there. I can start this, and now I can show you another tool. I can, here, again, when you're in a hurry, you get the wrong huge. That is okay. I log in to my Raspberry Pi, provided the network, okay. Wrong password, okay. And now I use another tool, VDE namespace, VDENS, which creates a user namespace directly connected to VDE. So, VDE namespace, and now I can say VDE. I got a user namespace. I'm just a user, no root access, no capabilities. And here, I can add an address, then VDE0, a p-link set VDE0 up, and now on the virtual machine which runs on my laptop, IP add 10.00, Raspberry was 2, so 1. There is an error in configuration. Dev ATH TH0 IP address. Okay, there is okay here. I've seen a mistake. There is not the mask, so I have to delete this and add the mask at the mask /24, otherwise it's not working. Ping 10.001, that's working. So the idea is this. Oops. I have to do it that way. Okay. The idea is this. You can have so many hosts, imagine a data center connected to the local area network, and then you can start any kind of VM namespace on any host in your local area network and connect it to VXVD as VXVD creates a distributed switch on the net is it implemented? The idea is that the VDEplug library, which is on H2, use IP multicast to send all the bound packets, broadcast, unknown recipients, and multicast packets. So if you're sending an ARP packet, the ARP packet is embedded in a UDP multicast packet and sent to a multicast address. So everybody is receiving, in that multicast group is receiving the packet. But in the same time, it gets the IP address and port of the sender. So, like a switch, this VDEplug learns that the IP address and port of this is the sender of the packet. So like a normal switch, IP address and port have the same meaning for this distributed switch as the port in a physical switch. So from now on, if this VDEplug can send just UDP packets, unicast packets back, it's similar to what happens with VXLAN. But VXLAN needs what is called a VTEP, a kind of switch, which is a switch that has to be configured on each physical host. Okay, physical host. Instead, this is completely distributed. You don't need any configuration. Just use the same multicast address and you get a network. Okay? And you can create a VDE namespace and plug it to the network. So, using VDNS, you can create a network of namespaces. So you can create namespaces and plug together as a network and decide that a number of tools as have their own address and they are working on the same network. Even if these tools are working, are landing on different hosts. Let me recall that if now you want to migrate the virtual machine to another host, you don't need any reconfiguration, neither on the host nor on the switches. And it is as fast as VXLAN, so you can have some everything costs, but the traffic is just UDP unicast, just with 50 bytes per packet of envelope. It's the same of VXLAN. So it works on any network. It works better if your network supports jumbo packets or baby giants, so more than 1,500 bytes per packet, if you are able to reach 20 to 2,000 bytes per packet. But we've done more. PAMnet is a PAM module, two PAM modules actually, that can give users their own networking environment, or even no environment. So I have a user in my laptop named Renzo non at, the name says all. So if I SSH Renzo non at localhost, try to write the right password. No, there is no way to make a presentation. Now, I have no network at all. So you can create dialing only accounts, okay? But this will be not many useful. Maybe you can give somebody just the processing power for your host without the ability to create further connection. But we would like these people to have the ability to create their own local area cloud, but private local area cloud, in a way that the local area cloud of a user cannot in any way interfere, send by error or on purpose packets to another net, or even tapping the network of somebody else. So we wanted these users to be able to create their own network. The idea has been implemented in the tool VDEX extended, which is a combination of a VDEplug plugin, a VDEplug tool, and a kernel module. This kernel module provides the user with the ability just to send packets to virtual networks, not to other hosts. And all the packets sent on the network by VDEX, I can say that they are orthogonal one to the others. So the network of user A has in a specific point in the header an ID, a virtual network ID, and the kernel module is able to let the user send only packets with that ID. And if by error, by on purpose, a packet is received on the wrong, with the wrong ID, it's just discarded. So there is no way from one user to interfere with the other. So, what's the point of that? What's the point? Imagine you have a data center. So you have a set of hosts, you have a set of users that want to do their own job. So now, if you give your users as a data center owner, if you give your user just the ability to run virtual machines, you can force your user to do just the right things by limiting the ability to configure their virtual machine. What we can do now is to give the ability to user to have full share access, and at the same time, they are limited to do just their own local area networking, local area cloud networking, not more. So, as standard users, there is no way to limit the access to the internet. As standard users, there is no way to limit the access to the local area network, because every user can open a socket, bind a socket to multicast address, and so on. You could write a log and bolting IP tables filter to say that user can do that. Instead, the XVD X-kernel modules provide a different address family, which is not AFNet, it is another family, in which the only operation permitted are those which permit to create the local area network of the user. Which is the point? Security is always a relative matter. So, my laptop is safe, it depends. If somebody is able to tap the bus, the system bus of my laptop, it is possible to read passwords, to enter the memory, and whatever. Which is this level of security in a data center? The model of XVDX is that no user must be able to tap the real line, and no user, apart the system administrator, should have unlimited shells. If all the users enter the system using PAM no-net, they can add VDEX networks and can create their own local area cloud in a safe way. Where is it done back? Doing this stuff, we believe in the Unix model to have several tools. Each one is doing its job in the best way that it can, and then you can combine all these tools to have services, to have a more powerful service. One tool we are creating is capability tool. It's like SUD, but at capability layer. It's not directly related to networking, but we needed it to provide, if we want, users with just the capability they need. There is a cargo.conf configuration file, and you can say that this user, that user can have this and that capability. Other tools, Slirp. Slirp is a famous piece of software which is in many virtual machines. It's in KMO, in KVM obviously, in using Linux, in VirtualBox. It creates an emulated IP networks that is able to emulate a router and permit to the user of the virtual machine to connect to the internet as if it were connected by a masquerade, not router. To create the new module for the code from KMO. We have taken the code from KMO exactly as it is. We have just added 3 lines to add an include file, so we can follow the evolution of KMO Slirp implementation. And we created a library. So if you need the Slirp in your project, now there is a library that provides Slirp facilities. So for example, I can create I can create a VDE namespace like this. Now, this VDE namespace is here, but there is a tunnel to Bologna where it runs a VDEslirp. So this namespace is in Bologna. I can show it. I can take how to configure the namespace using the ACP, and now I can run IceRacer, FOSDEM, IP. What is my IP address? Okay. We are in Bologna, Italy, but just this namespace has been moved, and I have no root access in Bologna. In Bologna, there is just one process that is forwarding my IP traffic as if it were a router, an active router. From the internet point of view, all the traffic I'm generating here, okay, it seems to be generated by my host in Bologna. Somebody is telling me that the time is over. Unfortunately, I would have a bunch of more things to tell you. So if you have, I'm begging pardon for this problem with the amplification. If you have questions, very quick question, please. No questions? I'm puzzled. I don't know if it's positive or negative. It's not neutral.
I actually do have a question, which is how far is this from production ready point? As in, should I want to use this in production right now on a really high performance network?
I think very close. How far is the state of the tools from production? So to use it in a real data center, is it very near? We are going to, very soon we are going to create packs for the distributions and to release to the general public. We have other stuff which is undergoing, like the self-generation of the IP, the 6 addresses by hash, so that you can just give a name to each process and the address will be generated in an automatic way. And there will be a DHCP server able to ask the DNS server which is the address that the host must be able to do both forward and reverse resolution. Okay, thank you very much.